Thank you for visiting my Snowflake Certification Knowledge Series video. In this video, I will help you understand the data type concept, primarily focusing on structured and primitive ones. On surface, they look very simple. However, when it is clubbed with micropartition concept, it becomes a little confusing to answer those certification questions during the exam. It is important to understand their behavior considering the best practices and how it works when stored. Many on-prem or legacy data migration need good understanding how data type works in Snowflake and what are the best practices around them. We will see what kind of data types are not supported in Snowflake. In this short video, we will cover data type fundamentals in Snowflake, keynotes, tips and tricks, besides sample questions with detailed explanation to reinforce your understanding. So, why this subject area is so important and how does it impact your success during the certification exam? This subject area is relatively simple with certain exception, and that's what certification exam will verify. Since Snowflake store data in micropartitions in columnar format encrypted, during exam they club data type with other concept to confuse you. Some of the data types are not supported and some of the data types are having storage size limitations, and all those questions will surely appear to validate your knowledge. Exam will not ask a lot of questions, but they would kind of validate data type with micropartition, with size limitation and its underlying behavior. So you can expect at least 3 to 4 simple or medium complexity questions from the subject area. I have already covered semi-structure data type like JSON, XML, Parquet, etc. in a separate video. In this video, we will only focus on a structured data type. All my videos are divided into smaller sections. We can call them chapters. You can refer them inside the video panel. As you can see here, that each chapters are having a demarcation. When you hover over those demarcation, you can see which chapter it is currently. And you can jump to the specific chapter by clicking. Alternatively, you can also click on the description section and you can refer those videos directly. This will help you to save time and navigate to the different sections of the video quickly. What is my primary intent to make these videos for you? Well, we all know that the Snowflake is the future of cloud data warehouse. Considering the fact I decided to be a certified Snowflake developer and an architect and spent around 6 weeks along my day job to clear the exam. I cleared the certification at the first attempt with fairly good marks. I was happy, but I was not very satisfied, especially after my certification attempt. I realized I could score nearly 100%, and some of the conceptual gap kept me away from the center. And hence, I decided to share my experience, the focus area, tips and tricks with all of you. If these videos helped you score better or near 100% or 100%, I would be very, very happy. So let's first look into the syllabus. If you look into the syllabus, 5D is what the data type all about, and 12A and B are all about the semi-structured data type. We will go through all the primitive data type in detail, and semi-structured data is already covered as a separate video. September 2020 onwards, the syllabus has changed, and along with this 15 topic, stream and task is also part of the syllabus. Let's start with primitive and structured data type. The concept of data types are very simple, and we are not going to discuss about the basics of data types. We are primarily going to understand those different data types and how are they different in terms of definition and in terms of usage in the Snowflakes. So let's start with the keynotes on the data types. So Snowflake has its internal way of storing data. On surface, it supports many style, but many of them are just alias. So for example, int and decimal both are numeric type and they are all stored as a number. So numeric, which is also a fixed as well as floating, and it can store up to 38 digits. Rest all numbers are stored with this data type, no matter what definition you give. So you give int, big int, small int, float, decimal, big decimal, everything will be stored as a number. String, binary, that is another data type which holds the characters. String, text and varchar all are varchar. Character, if you have not defined, by default it will be a varchar 1. If you define character 5, 7, it will take the varchar accordingly. Binary is another data type within the string and binary data type, and binary and var binary both are the alias for the same binary. Logical data type, which is Boolean and pretty standard. However, in Snowflake is started supporting from 25th January 2016. Date time equals to date. This is another data type, pretty common. It has a 6 different variants: time, date time, timestamp, local time zone, timestamp, no time zone, and timestamp with time zone. Important to understand, and I suggest you try all those possible data types with time and date and play with it. Sixth point, important one, Snowflake displays float, float 4, float 8, real, double, and double precision as a float. So when you describe a table or when you get a DDL for this one, even though get DDL will show float 8, but when you describe a table, it will always show float. Let's talk about fixed and floating, which is still a numeric data type, the keynotes on them. So numeric data type, which are fixed point like int, bigint, etc., all are numeric. It can hold up to 38 digits. When it comes to the scale for a floating data point, total number of digits right to the decimal point is 37. For example, like you can go up to 37 digits. Data converted from higher to lower and back to higher, it will lose its precision. So for example, that you have defined a data type called number. So by default, it will take 38 digits, but if you have defined 38 digits and precision is up to 37, when you convert it into the double, by which is having a 17 precision, and then when you convert it back to the number, it would lose its precision. So a question may come as a true and false. So precision, total number of digits, does not impact storage. Snowflake micropartition determine the min and max precisions on the data, and then it is stored the data. Scale, number of digit followed the decimal point does have an impact on storage. So for example, if you have a number which is having a precision value as a 5, and if you have another number which is having a precision 0, so certainly the number 10 by 5 would consume more space than the number 5 by 0 internally. Let's talk about some of the other facts on the floating point. So this is also a numeric data type which is classified as a floating point. Snowflake uses double precision 64-bit IEEE 754 floating point numbers. Snowflake support following special values for float. So obviously we know what is float, but there are some special values which is supported by Snowflake. So they are like not a number, infinity, negative infinity. And when you define this as a part of your ETL or ELT process, make sure that it is surrounded with a single quote. Snowflake displays float, float 4, float 8, real, double, and double precision as a float we have seen in the previous slide. Let's talk about constant and literal quickly. So E or a capital E indicates exponent. Example 1.234 e raised to 2 plus and minus. By default, if you do not specify anything, it will take plus. So fact on string and binary data types. So varchar holds Unicode character. Maximum length is a 16 MB for the varchar, and that is uncompressed. Very, very important point to remember. A question may come whether it is compressed, uncompressed. For a variant data type, it is a compressed. Single byte would take up to 16 MB if you have a big text. However, if you have a 2-byte character or a 4-byte character, then the total 16 MB would be 8 MB or 4 MB. If a length is not specified while defining a varchar, by default, it takes the maximum length, which is total 16 MB. Char or a character, same as a varchar. And if the length is not defined for a char or a character, by default, it will be varchar 1. For a character data type, no padding like a standard databases. So we know that if you have defined a varchar char of a 3, even if you give a single character value, rest of the empty fields will be padded with spaces, but that is not the case in Snowflake. Keynotes about binary. So binary is another data type which holds the text or a MIME type, has a length of 8 MB, no notion of Unicode character. So length is always same. So it's not a double byte or a 4-byte character. Where binary and binary both are alias. Internal representation, the binary data type holds a sequence of 8-bit byte. Let's talk about string constant and literal. Important one, string constant in Snowflake must always be enclosed between the delimiter, means like single quote or double dollar. Snowflake support using single quote or $sign to delimit string constant. In a standard database, single quote is used for a constant in a select statement, for example, this. However, if you have a escape character like a /t, /n/r, you can use a double dollar instead of a single quote. So two single quote is not same as a double quote character. So here we wanted to give a single quote or a double quote inside a string, and to have that you have to specify the double dollar. When you are having a double dollar, you cannot have another double dollar inside this delimiter. So I suggest to play with this constant literal using the select statement and see how the behavior is with a escape character like a /t /n/r, and also play with giving a single quote, double dollar between the two double dollar sign and see how the behavior is to reinforce the understanding about the string constants. Let's talk about a Boolean data type. It also has a special behavior, and that's why I have taken this slide. Boolean can have a true and false value, we all know. Boolean can also have an unknown value, which is represented by null in Snowflake. Boolean conversion. So when we try to convert a following string like true, t, yes, y, on, and 1, which translate into a true Boolean value. And if it is false, f, no, n, off, or 0, it translates into the false value. When you try to convert a numeric value to a Boolean value, 0 is always false. Any non-zero, whether it is positive or a negative, is always true. String and numeric conversion. So when you try to convert a true value or a false value, this is how it works into the lowercase true and lowercase false. And in number, it is 1 and 0. Null is converted to a null. So please try all those possible options. It is difficult to remember. So once you try before the exam, it will reinforce how this string and the numbers are translated into the Boolean values. So let's talk about a date and time, some keynote on it. So we all know date data type for storing dates with no time element on it. Date supported formats, pretty standard one. When a date only format is used, the associated time is assumed to be midnight on that day. Timestamp, which combines a date and time. Date time is alias for timestamp, no time zone. So please remember that. All accepted time zones are valid input for date. Time data type for storing time is in form of hour, minute, and second. This is also important. Time supports an optional precision parameters for fractional seconds, which is, for example, time 3. Time precision can range from 0 seconds to 9 nanoseconds. The default precision is 9. All time values must be between 0000000 to 23:59:59, 9 nines. Time internally stores wall clock time, and all operations on time values are performed without taking any time zone into consideration. So very important point for remember. Also for a practical purpose, this time related operations are super important. So I expect you to go and play with the time. Snowflake also uses the Gregorian calendar. So there are also date and time constant. It is a pretty standard in Snowflake. So you can use like a string literals and string constant to define the time and the timestamp. Let's talk about interval constant. So interval constant to add and subtract a period of a time to and from a date data type. Example, like you can add 1 year, you can give an interval of 4 years, 5 months, 3 hours, and interval of 1 year, 1 day, and you can perform that add and subtract. So you can see the number C and D, it is exactly same, but there are some differences the way the operations are performed. So in this example, I am taking a date and I am adding an interval of 1 day, 1 year. Okay, the result would come like this. And in the same thing, if I perform 1 year and 1 day, the result is slightly different. So please remember that this operation happens, and unless otherwise you try with some simple examples, it will be hard to remember and attempt an answer during the exam. Interval is not a data type, and it can only be used with the date time data types. A simple arithmetic you can perform on the date. So if you say that I'm going to use +1 or a +4 or a -4, it would work like this. So try it out. Let's talk about time zone, date, and time format. Okay, so I have taken some examples. So you can set a time format like 24 hours clock time. And when you do this current time 3 and current time 6, it will give the result accordingly. And if I have again changed the time zone, if I run the same query on the screen, it would result like this. So please try all the date time operations, Boolean operations, floating operations, get DDL functions, describe table, and try to have a varchar, and all those things are very important. There would be a simple questions which you would assume that you are attempting right answer. However, on reality, it would really not match the expectation. So my suggestion is that try all those sequels and get your hand dirty. Before we start the questions and explanation, I would like to have my disclaimer. All those mock questions are just a representation based on my experience and are indicative. The scope of the content in the exams may evolve, and that's why I prefer that you please refer the current syllabus and the Snowflake documentation and have this mock question as a reference to help you. Before we start, let me help you how to navigate these MCQs. Along with question, the type also appears, which indicate if it is a true and false, single or multi-choice question. The Snowflake certification exam also helps candidate with number of correct options in case of multi-choice. Here I am not following that approach to make sure you find the solution by yourself without any hint. Options appears one by one, and once all the answers or options appeared, you can pause and attempt the question. Finally, the question complexity and confusing indicator also appears along with the correct answer. An emoji also is added just to make sure that if this question is a confusing question or a straightforward question. And finally, explanation text and any supporting document, if available, would appear on the screen. So let's start with 15 mock questions and assess yourself whether you are able to answer all those questions properly or not, even though it is a very simple topic. But I know people make a mistake and don't go with that overconfidence. Please try those SQLs and then attempt these questions. All the best. Question 1, true and false. Question 2, question 3, question 4, question 5, question 6, question 7, question 8, question 9, question 10, question 11, question 12, question 13, question 14, question 15, and the last question. These are the following resources and documentation link. This concept is relatively straightforward. However, there are some differences, and to reinforce your understanding, please try practicing the SQLs. All the best for your Snowflake certification exam. You can refer the description section of the video for important links and reading material. Please do share and subscribe to my channel so you can get notified when the new Snowflake certification content is published. If you find any one of the content or the information is incorrect or inappropriate or not aligned with the Snowflake documentation, please share your feedback via comment section.